Today we discuss how to take the cost out of design, build and monitoring of distributed systems. Designing distributed solutions, where components running on networked computers coordinate their actions through exchange of messages, is hard to prove and almost impossible to monitor once live. Many rely on visual inspection of design artifacts and then run test cases against stub or real services. This is only as good as the people doing it. There is no inbuilt mathematical rigor to either approach, and therefore no guarantees that the design will not result in flaws such as deadlocks or live locks. It's difficult because, unlike process orchestration, where a centralized controller decides what happens next, in distributed solutions, the locus of control passes from one component to another. Consequently, design issues tend to be spotted late in the development cycle, sometimes not until live, when they are also hard to diagnose and fix. We have a better approach, based on mathematical proofs, which allow us to check the evolving design, accelerate implementation, and both monitor and enforce the process at runtime. Scribble is a formal, unambiguous, machine-processable and human-readable language for describing the exchange of information between two or more participants, a choreography. It allows us to build a complete description of the system's types and how they interact, such that we can apply the mathematical proofs to identify any problems with that design. Think of the model as a union of existing design artifacts. Each new artifact, such as a sequence diagram, is checked against the model to ensure new behavior does not break existing types. The Scribble type system, part of the compiler, performs this type checking to ensure freedom from live locks, deadlocks, race conditions, and other unintended consequences. Once built, the model is also applied to the running processes, checking off each interaction as it occurs against the expected choreography, and raising errors where unexpected behavior occurs. Our engagement model is simple. We produce an early Scribble model to give you instant feedback on how well the design will work. We then generate the local types, the endpoints, as Java microservice stubs, injecting key features such as a finite state machine, logging, role-based wait times, and validation of inputs against outputs. We deploy the microservices in OpenShift, an open source PaaS based on Docker and Kubernetes. This means we can add functionality to the stub implementations, or swap them out completely for the real implementations, simply by changing endpoint bindings within OpenShift. Next, we generate test cases directly from the Scribble model, using the business flow of events to give a robust regression test mechanism. The final step is to monitor the live service. For new systems, this is easy, as we already have the model and can simply check off the process steps against it as they occur. For legacy systems, we also monitor the logs, but then use these to infer the types and hence overall choreography model. We call this the voice of the machine, which we can compare with the intended behavior, the voice of the business, to discover whether live systems are delivering the expected and needed business processes. Our approach is unique and the result of partnership across a number of leading universities, including Imperial College, Edinburgh and Glasgow. For us, this is about applying distributed system theory to the real world to save you time and money.